Good afternoon, everyone. Hi, I'm Ekaansh. How many of you are React developers? Okay. How many of you are not React developers? Awesome. So a mixed crowd. That's what we like to see. So we'll be talking about full stack type safety. Anyone of you who's heard this term before or used some of the things around this before? Show of hands. Perfect. That's exactly the type of crowd I'd expect to be here. So we'll talk about full stack, whichever spectrum you belong to. There should be something to take away from here. And I like to talk about this as move fast and break nothing, based off of Facebook's move fast and break things. So let's get started. That's me. I'm a developer advocate at Agora. So like obsessed with developer experience and making developers' productivity better with like tools and things. I speak JavaScript, TypeScript, and I also maintain some of the UI kits and do a bit of open source. So what does full stack look like from like full stack type safety? Let's define full stack, right? So there's usually your three pieces or three layers. There's your front end client, there's your back end, and there's your database. You have something like an API communicating between your front end and your back end, and you have some sort of a query that you use to interact with the database. So far, so good. Now, what is type safety? Does anyone know what's type safety? Show of hands. Do you want to yell what's type safety? It's type safe, right? It's hard to describe. So it's why people like TypeScript. How many of you like TypeScript? How many of you hate TypeScript? Okay, we'll get you around. But Wikipedia defines this as the extent to which a language discourages or prevents type errors, right? So this is when you do like a type conversion. For example, you define an integer and then you dynamically allocate it as a string, and then you run into all sorts of errors. That's what is the problem with not having a type safe language. And JavaScript itself has always been very type unsafe. So for like just dumb it down, it's the red squiggly line that you see in your compiler which tells you that hey, you're writing a bug and you should probably read your code again. For example, if you try to tell me that Angular is the best framework, your compiler will yell at you and tell you that you're wrong. Okay, awesome. So coming back to full stack type safety, right? I like to think of it as when you're crossing a boundary in your stack. So let's say this is our stack and the red squares are your boundaries. Whenever you're crossing a boundary in your stack, do you have access to the previous system's type information? And this feels like a mouthful, but essentially what we're saying is when you're going from your backend to your front end, do you still have access to your backend's types? Let's say your backend is in Node.js, or let's take an example, okay? Let's say we have React, Node, and MySQL. Let's say you write some types in Node. Do you have that information in your React front end? Usually not, right? Because you'll send like a JSON and then you parse it on your front end, and you lose all sort of like type information that you could have inferred from your backend. And that's sort of the problem in that layer. Let's talk about your database and your backend. So traditionally, SQL has other data types like varchar and like other data specific types, which are not part of JavaScript. So usually what happens is you do like a query and you try to insert a string inside a date and things just blow up. So what if you could avoid this using like a simple tool? How many of you have heard of Prisma or an ORM or a query builder? Cool. So Prisma is sort of this layer which sits on top of your database, and it lets you interact with your database in JavaScript or in TypeScript. So you can define your table or your model with TypeScript. So for example, I can say title is string, and that doesn't mean like you don't have to map it to a varchar or define the length of it. It just infers what the data type should be from your TypeScript bindings. And this is really cool because you can now be very confident if you do a Prisma query, your database will not blow up. That's a guarantee. So we solved sort of the first interaction between the DB and the backend. This is not new. This has been going on for a while. Like you have ORMs in Golang, JavaScript, all of these different languages. What I'm more excited to talk about is this piece. And that's where you sort of send a JSON and you have this object and you try to read a property and you just find out that someone changed the API overnight and now your front end doesn't work because URL was not described on this object that you're reading. And it's the worst kind of errors, right? Like everything was working yesterday and today nothing works. Yeah, you can do conditional checks and you can do a lot of boilerplate around avoiding these errors, but there's a better way. And this is sort of inspired by GraphQL. How many of you have used GraphQL? How many of you like GraphQL? Okay, so less than the people who use. I am not a big fan of. I really like GraphQL and the way it prescribes things, but I feel it's a bit overkill in terms of day-to-day applications. If you're building like a simple app where you want to stub out like 3 API routes, GraphQL is probably overkill, right? Like you don't want to define your own schema. Your database does not probably exist in graphs. You don't want to write resolvers in your backend. It's a lot of effort. So we're going to talk about something different. We're going to talk about TRPC. So far, this is my pitch to sort of sell TRPC to you. It's completely open source. It's free to use. It's a great tool. I have enjoyed myself using it. And that's what I'm going to talk about and show you like a demo of in the next like 5-10 minutes. So that's how I feel using TRPC and using full stack type safety, because front to back, there's no type errors, nothing blows up, and everyone has a great time. So let's look at some source code, and we'll jump into VS Code. This is a standard Next project. How many of you have Next? Great. So for those of you who've not used Next, it's like a meta framework built on top of React. Think of it as React with like a backend integrated. It's really fun. It's really well made. So we have a home component, or actually let's first go and look at what this app looks like. Let's see. And let's go back. Cool. So we have a simple input. You have a create and a delete. So this wipes out the database. And if I insert, let's say, hello React, and I create, it just inserts it to my database, updates my front end, and this is like a simple CRUD, right? There's 3 fields. You have some ID, you have some text that I entered, and you have a date. So let's look at how this works. So you have your home, which is just like a layout where you get this query. How many of you used React query or TanStack query? It's the best. It's arguably the best way to fetch data in React. And if you haven't tried it out, like I would 100% recommend giving this a shot. So TRPC binds over React query and gives you React query hooks. So there's something called a use query hook, which gives you this object, which has properties like these. Yes. This is better. All right. So this gives you this object which has a lot of important properties or interesting properties like data, is loading, is error. So it gives you all the nice primitives you would need to sort of show a loading spinner, show an error screen, and things like that, right? So this get data has something called the data, and I can map over sort of the different fields, which I sort of showed you here. So if we have multiple objects, it'll map over them and sort of return like a list. Now, what's interesting is once I have access to this data, I get type completion on all the properties. So if I access like a property on this data, it clearly tells me what is available in my API. And I don't have to sort of coalesce or describe this type. This type comes from my backend. So let's take a look at that. This is my query. It's called get all. I'll control click on get all and I go to my backend. So this is what my backend structure looks like. We have things called procedures. Procedures are nothing but like your API endpoints. So we have something called get all, which goes to Prisma, finds all the items in my database, orders them by when they were updated, and returns them to my front end. And what's cool is essentially, if I describe my database here, this is what my SQL table looks like. That's the only place I have to describe and do write types for my data. So another way to think about this is, the problem with TypeScript is you have to write a lot of types, which people don't like doing. So once you've described your type here, Prisma creates a type called example for you, which can be inferred here directly. Since I'm finding things on the example table, it knows exactly what I will receive, and that type is inferred in the front end. So if you see here, this type example, this would be removed during compilation and would never reach my front end. But it's nice to get this type hint of telling me that, hey, data.id exists. And if I try to say data.id plus 123, it'll give me like, oh, this is a string and this is an integer. And you're doing something that you probably shouldn't be doing, right? What else? Let's see. Another cool thing is you don't have to if you've dealt with dates before in your backend, you probably would convert it to a timestamp, send it to your front end, convert it back to a date object, and then access properties on that date. What you get here is sort of this date object, which is properly serialized, and you don't have to worry about serializing it, passing it into a JSON, converting it back into its data type. All of that happens automatically. Let's take another look at sort of how to mutate or how to do a mutation. It gives you things like create and remove, which you describe as mutations. And when you call this mutation, it knows what you need to pass in, right? So it'll give you type hints that it expects a text. And if you try to pass in a text as an integer, it'll give you like a type error. It'll tell you that, hey, you expect this to be a string. When you're passing this to your backend and inserting into your database, this will cause an error because your database expects a string. And you infer this type right into your front end. This is sort of the magic of TRPC. So let's change it back to the input. The type error should go away. And let's take a look at what this looks like on the backend. So you describe a procedure called create. You describe an input. You tell it what all fields you want. So let's say we added text and we described it as a string. Now, once this validation passes, only then the mutation will be called. And you can now update your database, and you'll know that this always will be a string, as long as you're following, your compiler's like suggestions and errors. Yeah, so that's pretty much it in terms of like the three layers that we talked about. Let's quickly go back and sort of see what that looks like. So going back, so your front-end client knows what your database wants through your backend, and you only have to define the types once. And it's really easy to set up. Like it's 10, 15 lines of code to get started. There's no resolvers like GraphQL. There's no extra boilerplate that you have to write. So let's come to sort of how do you get started with this, right? Like these are some cool things. I'll leave out the slides on Twitter so you can like go through, sort of how this works in terms of there's a very tiny client-side footprint. If you were using like React Query, that's all the bundle you have to byte. Great DX. There's no code gen. So with GraphQL, each time you update your schema, you have to run the code mod to sort of update your schema and get type hints. But here, as soon as you change your database, or here, for example, if I change, let's open this up here, and this is my favorite part to sort of demonstrate. This is my front-end code. This is my back-end code. And here, if I sort of rename, let's say, the input, let me find that out real quick. This input, and let's say I want to rename this to, I don't know, example. There's no code mod. My backend gets updated instantly. Isn't that magic? Like you change your front end, you don't have to go to your backend person and ask them to update the API. If your backend person changes a variable name, it just reflects in your front end. There's a lot of coupling, but there's so much better clear communication between what the backend wants and what the front end receives. It's once you use it, you just can't go back to like a traditional REST API. So that's my pitch essentially. There's something called Create T3 app, which gives you like a CLI to scaffold a boilerplate to get started with Next, TypeScript, TRPC, Prisma, Next.js, Tailwind, all of the cool things that people are talking about. It simplifies all the boilerplate that you would have to set up yourself. Shout out to all the cool people working behind TRPC and Create T3 app, and you folks for being patient and listening to me rant for like 20 minutes straight. I'm Ekaansh. You can follow me on Twitter if you want to look at the slides or look at the code for the project. And that's been it. Thank you so much.